Good morning, class. We are looking at section 6 that involves phase shift, or better yet, 6.1 and 6.2, more graphs of trig functions. So we continue with the concept of graphs. So we've looked at graphs of sine and cosine, other functions such as tangent, cotangent, cosecant, and secant. And now we're going to add PS, phase shift, and sinusoidal curve fitting. The way they write it, depending on the text, y equals a sine, parentheses omega x minus phi plus b, okay? We take the omega out, we get a sine omega of x minus phi over omega plus b. In some, they may use b here, c here, and d here, okay? So again, in some text, they may write this one as a sine b x minus c plus d. It's just a matter of, taste, if you will. So I just want you to be exposed to that. All right. You remember how to graph sine and cosine functions. Here's the 2 pi cut into 4 subintervals. And here's the endpoints, the value for the endpoints for sine, the value for endpoints for cosine. And there are 1, 2, 3, 4 arcs, 1, 2, 3, 4 arcs. So you graph 4 arcs. That's what we do for sine and cosine. And the general information is that the period is 2 pi, amplitude is 1. Okay. And if you have a coefficient in front of x, you divide by that coefficient, see, 2 pi over omega. And if you have a in front of sine or cosine, the amplitude changes from 1 to absolute value. In the case of tangent, we graphed it by knowing that it's sine over cosine and looks almost like y equals x cubed. Pay attention to a complete cycle that goes with VA being x equals minus pi over 2 and x equals pi over 2. The graph looks like that with 3 key points. This is 0, 0. This is pi over 4, 1. This is negative pi over 4, negative. In the case of a cotangent, looks almost like y equals negative x cubed going this way, but it's shifted to the right compared to that. So one complete cycle is this from 0 to pi, everybody. X equals 0, x equals pi would be the vertical asymptotes. The intercept happens at pi over 2, so pi over 2, 0. This is pi over 4, 1. This is 3 pi over 4, negative 1. In the case of a cosecant, you graph sine, you flip it over. And it causes the domain be everything except n pi, and it causes the VA to be in pi. And it changes the range because from negative 1 to 1 is not covered anymore. For secant, you flip over cosine. So you graph cosine and flip it over. So that gives you the same range as here. Okay. And the domain, whatever the denominator is 0 is out. Cosine is 0 as odd multiples of pi over 2, and that makes it the VA. So very straightforward, everybody, just reminding you of what we have seen. And now, what happens when we have a phase shift? We graph sinusoidal functions, one cycle, a complete period, a complete cycle. Y equals a sine omega x minus phi. The period is 2 pi divided by 5, phi, and we are assuming everything is positive, a, omega, phi, you name it. And so in that case, as I mentioned in the first place, we really want to take this one out, okay? Then it makes it easy to see this is the phase shift. Do you see that? So if you happen to have it in this format, you take the omega out, I can't emphasize this enough, then the amplitude is the absolute value of a. The t is 2 pi divided by omega. Phase shift is this, phi over omega, okay? And plus b goes up and down along the y-axis. Phi is less than 0. If it's less than 0, so if, for example, we have plus here, then PS, meaning phase shift, is to the left. And if it's positive, it's to the right. So very straightforward, everybody. All right, here's the summary steps. If you want to graph this, okay, first come up with the amplitude. The period is 2 pi over omega. Phase shift is phi over omega. As I said, bring the omega out. Determine the starting point of one cycle. Determine the ending point, and add that phase shift and divide the interval, see, from the beginning to the end into 4 subintervals. So we are looking at the 5 keys. Use the endpoints of the subinterval to find the 5 key points. Plot the 5 key points, graph them. Now, I'm going to show you with examples, so you don't have to worry about that, because it's a lot easier if you see a simple example. For example, we want to graph minus 2 cosine of 4x minus pi, and we want to see how we do that. And this is the information we have for a case like this. So first and foremost, I'm going to take the 4 out. So the amplitude is the absolute value of negative 2 or 2. The period is 2 pi divided by 4, or pi over 2. That means we are going to go from 0 to pi over 2 on a regular basis. However, the phase shift is a positive pi over 4. So if there was no phase shift, this would be a complete period from 0 to pi over 2. We're going to shift this to the right, everybody. So I hope you see the effect of that. So we're going to add pi over 4 to this. And the result is 0 changes to pi over 4. Pi over 4 and pi over 2, they add up to 3 pi over 4. Now, we're going to cut this into 4 parts. So we know, because in order to cut this into 4 parts, okay, their difference must be cut into 4 parts. And their difference is the same as difference here. So pi over 2 divided by 4, or pi over 8. Remember, the period originally we calculated as pi over 2. This is the distance between these two, or these two, that we're going to cut in 4 equal parts. So the first one is pi over 4. The second one, we're going to add pi over 8. The next one, we're going to put another pi over 8. The next one, another pi over 8, until we get to 3 pi over 4. So take a look at what happens. This is the interval of interest. We want to get to 5 key points, 4 subintervals. Starting with pi over 4, add pi over 8. So you get 3 pi over 8. I want to make sure everybody knows what that means. That means we have pi over 4, 3 pi over 8. The second one is 3 pi over 8. Add another pi over 8 gives you pi over 2. Here's the second subinterval. The third subinterval, pi over 2, add, you get 5 pi over 8. The last subinterval, 5 pi over 8, as expected, we get 3 pi over 4. So again, a quick recap reminding you about the 5 key points. Here's the complete interval. You cut this interval into 1, 2, 3, 4 equal subintervals. You evaluate the function at the endpoints. Starting with pi over 4. You can put it here or here, it doesn't matter. It's easier if I put it here. If I put pi over 4 here, class, this becomes 0. This becomes 0. As you know, cosine of 0 is 1 times -2 becomes -2. Okay? I'm going to do one more because I want you to see what happens if I evaluate it at 3 pi over 8. If I put 3 pi over 8 here, minus pi over 4 or 2 pi over 8, it becomes -2 cosine over 4 times pi over 8 or -2 cosine of pi over 2. You know cosine of pi over 2 is 0. So I calculated the second. So I calculated this pair for you, this pair for you. Now plug in pi over 2 becomes 2. I'm going to leave the rest of them to be done by you. It's very straightforward. All you have to do, plug it into that. And so plot 5 pairs. As you can see, if you remember cosine looking like that, but it flipped over because of the negative sign, and you continue indefinitely on both sides. Okay, I hope everybody is comfortable with the concept. We look at a couple more examples, becomes easy, everybody. We want to graph this. Again, I'm going to, first and foremost, I'm going to take the 2 out. Three, absolute value of 3 is the amplitude. Period for sine is 2 pi, so we divide by the coefficient 2, and it becomes pi. So if the period is pi, we're going to go from 0 to pi instead of 0 to 2 pi normally. If there is no phase shift, but there is a phase shift of pi over 2, that means this moves to the right by pi over 2. That's the phase shift, everybody. This moves to the right by pi over 2. We are going to add pi over 2 to this, meaning now we have to go from pi over 2 to 3 pi over 2, okay? This is really the key, understanding how we arrive at it. So a quick recap. Amplitude, the absolute value of that. I take the 2 out, divide the 2 pi by it, okay? 2 pi divided by omega. That gives us pi. That is the period. Normally the period is 0 to pi. However, because of the phase shift, moves by pi over 2 to the right. So just for the sake of argument, so we understand what's going on, so somewhere here, okay, let's say this is pi, this is pi over 2, this is 3 pi over 2, and 1 complete cycle. It's going to go from here to here somewhere. Okay, we are going to graph it from here. This is the period of interest for 1 complete cycle. So now we need the 5 key points. To come up with the 5 key points, we cut the period pi, this one, we cut it in 4, and we start adding to pi over 2 until we get those 4 subintervals. So t divided by 4 is pi over 4. And so here's what we have. We are going to add pi over 4 to the endpoints until we get to the right. Okay, and again, I want to show you what this is, class. This starts with pi over 2. When we add pi over 4, it gives us 3 pi over 4. That's the first subinterval, everybody. Now, 3 pi over 4, we add pi over 4, we get pi. This is the second subinterval. Pi, we add the same pi over 4, it gives us 5 pi over 4. So the next one is pi, 5 pi over 4. Finally, 5 pi over 4, when we add pi over 4, class. Since this is the fourth one, you should get this number, and you can do it. 6 pi over 4 is 3 pi over 2. You must get the last one, and you do. And this is 3 pi over 2. So now, notice what you need to do. Now you have the beginning, see, pi over 2, and the end of each one. That's why I put them in green. 1, 2, 3, 4. Those are 5 points. You have to plug it into either this one or that one to come up with the answer. Sometimes it's easier with this one. Sometimes it's easier with that one. It doesn't matter as long as you figure it out. So, for example, if I put pi over 2 here, they cancel each other, we get 0. Sine of 0 is 0. So pi over 2 gives you 0. What about 3 pi over 4? Let's just show 3 pi over 4. If I put 3 pi over 4 instead of x, I get 3 pi over 4 minus pi over 2 is 2 pi over 4, which makes it pi over 4 times 2 is pi over 2. 3 sine of pi over 2. As you know, sine is 1, so it's 3. I'm going to do one more. I want to make sure that you see how easy it is to calculate this. This time, so what did we do? Pi over 2, we did 3 pi over 4. Let's do pi. Let's do pi. So if I put pi here, what happens? I'm going to write it here. I get 3 sine. Okay, pi minus pi over 2 is pi over 2 times 2 is pi. So 3 sine pi is, as you know, sine pi is 0. So it's 0. You can figure out the rest, okay? Everybody okay with that? So I did this one, class. I did this one, and I did this one. This, you can try it on your own. You're more than welcome to ask me if you like. And so when we plot, it looks like this. Again, look at what I had here. I want for pi over 2, okay? I want for 3 pi over 4. I want for pi, I want for 5 pi over 4 and 3 pi over 2. So this is a complete cycle. We're going to go to the left and right indefinitely, and that's the final answer. Let's do one more. Again, I'm going to take the 4 out first. As far as this one is concerned, negative one, that remember it shifts it down. In some cases, people ignore that. And let me explain how you deal with that. That might actually make it easier. The way they deal with that, they say, this is the regular case, right? Now I've got to go down by 1. So they draw this line, y equals -1, and then just deal with this class. But instead of, for example, if 0 gives you 0, and that's not the case. For example, this will give you 0, 0, right? And 0, 0 normally starts here, but you don't. You start from here, okay? If you do that, you can completely ignore that. I hope everybody's understanding. I'm talking about the transformation. That may be one easy way to deal with the transformation, this way. But let me go over the phase shift to make sure we're okay with that. So I'm going to erase the mess. And so we did that. And so now the period is 2 pi divided by 4. Amplitude is 2, of course, the absolute value of 2. 2 pi divided by 4, and it makes it pi over 2. So normally it's 0 to pi over 2 if there is no phase shift. If there is no phase shift, because the period is pi over 2, it starts from 0, 0 to pi over 2. But because of the phase shift, we add 3 pi over 4. By the way, if it was plus, we would subtract 3 pi over 4. So when you add 3 pi over 4 to 0 becomes simply 3 pi over 4. When you add it to pi over 2, change the pi over 2 to 2 pi over 4. 2 pi over 4 and 3 pi over 4 is 5 pi over 4. Okay? So that is your starting point. We're going to divide. So we are repeating the same thing. We're going to divide the period into 4 equal parts. When we divide this one by 4, becomes pi over 8. So what do we do? 3 pi over 4, we add pi over 8. And pi over 8, and pi over 8, and pi over 8 until we get to the end. So we are going to add, we're going to start with 3 pi over 4. We're going to add pi over 8. I've explained that to you. We get to 7 pi over 8. So right here, just to give you an idea, when you add that right here, the first sub-interval class, 3 pi over 4, 7 pi. The second sub-interval, 7 pi over 4. You add pi over 8, you get pi, so pi. The third one starts with pi. When you add 3 pi, when you add pi over 8, when you add pi over 8 gives you 9 pi over 8. And finally, 9 pi over 8. And the other end. All right, so let's evaluate this as at 3 pi over 4, starting with the first point. If I put 3 pi over 4 in here, it becomes 0. What I want you to notice is this and then that. So if this is 0, 4 times this 0, let me write that. If I put 3 pi over 4, I get 2 cosine 0 minus 1, and I get 2 minus 1. And I want you to pay attention to 2 because everybody, we can just be concerned with 2, the same thing for the next one and the next one, and then shift it down by 1 in one shot. I'll show you both ways quickly. So at 3 pi over 4, we get 2 for 2 cosine, and then if we subtract 1, we get 1. Now let me put the next number. Let's put 7 pi over 4. 7 pi over 8, my bad. This is 7 pi over 8. Okay. I'm going to put 7 pi over 8. What happens if I put 7 pi over 8 minus 3 pi over 4, meaning 6 pi over 8. So we have pi over 8. So it becomes 2 cosine of 4 times pi over 8. 4 times pi over 8. Pi over 2 minus 1. As you know, cosine of pi over 2 is 0, so we get minus 1. So again, you can either deal with 0 and then shift it down by 1, or just write here minus 1. Let's do one more. Let's do pi. Let's do pi, everybody. Let's plug in pi. Let's plug in pi. What happens if I plug in pi? I get pi over 4. This is pi over 4. Times 4 becomes pi. So this becomes 2 cosine of pi minus 1, everybody. And 2 times minus 1 is negative 3. So we get those pairs again. I did this one, did this one, I did this one. I want you to check those on your own. And as far as the graph is concerned, class, a complete cycle. This is graphed without any attention to negative 1. Please understand, this is without the negative 1. And this one going down, okay, by 1. So this is the graph of y equals 2 cosine of 4x minus 3. All right, we are going to build up sinusoidal functions. If you happen to have a function like that, what you should notice is that the amplitude is the largest data minus the smallest divided by 2. To evaluate the b, largest value plus smallest divided by 2. To determine the omega, remember t is 2 pi over omega, so omega is 2 pi over t. And the horizontal shift was phi over omega when it comes to that, because you are going to factor the omega up. So with that being the case, and the information that we have here, we want to write an equation of a sine function here, class, and the amplitude is given, the period is given, and this is given. So compare that. So in essence, put that here. T is 2 pi over omega. So omega is 2 pi over t, which is 3 pi. So 2 pi over 3 pi, or 2/3. We are going to use this, right, everybody? We are going to use this. Replace the a with 3. Replace the omega with 2/3. Replace the phi over omega with negative 1/3 minus negative 1/3 makes it plus. There is no b. And you can leave it like that, or if you distribute, then you get 3 sine 2/3 x plus 2 over 9. Okay.
I have a question.
Sure.
For the given that the absolute of the amplitude 3, can it be negative 3 for the
Yes, you can write negative. There is not enough information to mention it otherwise, but you can go with the positive because it's easier. But you are absolutely correct. Absolute value of a is 3. You can use negative 3. There is no information here that can tell you otherwise. However, if you have a choice between 3 and negative 3, if you're given the choice, stick with the 3. So again, I repeat, you are 100% right. Absolute value of a is 3. This implies the value of a is plus minus 3. You can choose any of them, but stick with the positive unless otherwise mentioned, or there may be other ways to find it. Sometimes there may be a pair given, which definitely makes sure you know it's positive or negative. Draw a scatter plot and find a sinusoidal function of the form y equals a sine parentheses omega x minus 5 plus b that fits the monthly temperature data for Indianapolis. So we want to find that. This is the information. And we are going to start. So in essence, this scatter plot is given to us. For example, January month of 1 is 28.1. February, the second month is about 32.1, so on and so forth. Okay, so we go from January all the way to December. We have the months along the x-axis, meaning 1, 2, 3, all the way to 12. Month 1, 2, 3, all the way to 12. And we have in the vertical axis the temperature. So 1 through 12, temperature. Maybe I write, here's the temperature, okay? And here's the months from 1 to 12. Okay, from 1 to 12. All right, so we have the information here, and we start with the amplitude is max minus mean divided by 2. This has the largest value, this has the smallest value, and we can read it from here. Okay. 75.4 minus 28.1 divided by 2 gives us 23.65. The vertical shift B is max and mean divided by 2. Now let's add them up, the same numbers. Add them up, divide by 2. This is how you find, this is the process by which you find the B. The period is 2 pi over omega, and we take it to be 12 months. So omega is 2 pi divided by t, which is 12, and it makes it pi over 6. Now, let me remind you of something quickly, class. If you remember the basic sign. Take a look at the basic sign. And by no means this is to scale. Or let me clear this part and use a different color. Okay, remember the 4 arcs, right? There were 4 arcs. And whatever the period was, if you cut the period in 4 pieces, gives you the interval or sub-interval of each arc. You remember that? So t is 12. If you divide it by 4, makes it 3. So the x coordinate, okay, so that's the case. And the x coordinate of the maximum value, July, okay. Remember here's, let me just, again, I want to stick with that one. What is this? This is 1/3 of the way, 1/4 of the way, and it's the maximum value, whereas this one is the minimum value, according to sinusoidal functions, okay? So month of July is number 7. This distance must be 3. So therefore, if instead of 3, remember, it goes from 0 to 3, class. Starting from 0 goes to 3. We are just, let me again, a different color. We are just concerned with this part. Okay, just the first arc, And here's the maximum. And we have this distance of, remember, 2 pi over 4, right? Or pi over 2, or in this case was 3, right? In this case was 3. And it has to go from 0 to 3. But if it's gone to 7, it's gone more than 4. So 7 minus 3, it has gone 4 more than usual. The usual is 0. That means the phase shift must be the difference between the two. Let me erase them. So that means the phase shift must be 4. And now we write the formula. We replace everything that we have. A, 23.65, sine of omega pi over 6. X minus 4 plus b. And that's the final answer. Here's what you need to do just to make sure that you haven't made a mistake. You must check if you plug in 1, it should give you about 28.1. If you plug in 2, must give you 32.1, so on and so forth. You must check this, everybody. You must check this, and I can't emphasize this enough.